Welcome to question number 20. Owls are a beautiful creature of nature. When I talk about owl, what comes to your mind? They have perfectly symmetric circular eyes, right? And this question is going to be based on geometry of an owl's face. I am asking you to calculate the area of the rectangle on the owl's face. Here it goes. Question number 20. Calculate the area of the owl's rectangle ABCD. The only toolkit which I will be using in this problem is the law of tangents and circles, which you can watch here. Let's get straight to the solution. I'll start by describing the geometrical construction here. Let us start by drawing a circle. So this is a circle with center O, radius R. Center O and radius R. Let us consider a point P which is 3R distance from the center O. So this is our point P and the distance between O and P is 3R. Let me connect the points O and P with a line, straight line. Okay, so this is our straight line OP. Next, I'm going to draw two tangents from point P to the circle O. So this is our first tangent. Let me adjust it properly. Okay, then this is our second tangent. Let me make it exactly tangential. Okay, so these are the two tangents from point P to the circle O. Remember, at the point of tangency, the tangent and the radius are perpendicular to each other. Let's call the point of tangencies as R and R prime. So this is R and this is R prime. And the line from R to O will be perpendicular to line PR. Similarly, R prime O will be perpendicular to PR prime, right? That's the law of tangents and circles. Let me draw the lines OR and OR prime. So this is OR and OR prime. Remember, both OR and OR prime are equal to the radius R. Now, as per law of tangents, the line OP bisects the angle RPR prime. Let's mark the angle RPO as angle theta. So this is our angle theta. Okay, next we are going to add to this construction. I'm going to add another circle identical to this circle O and place it right adjacent to the circle O, so that these two circles are tangential to each other at point K. So I'm copying this circle and pasting it, and I'm going to place it right next to this circle O. Okay, I have placed it as precise as possible. Next, I am going to draw another pair of tangent from point P prime. Okay, before that, let's call the center of our second circle as O prime. So this is O prime. I am going to draw two tangents from point P prime to circle O prime. Remember, P prime, P, O prime, they all lie on a straight line. So this is our next pair of tangents. So this is one tangent. Then I'm going to draw another tangent. Let me adjust this properly, precisely. Okay, then the next tangent. Okay, so let's call the points of tangency as Q and Q prime. So this is our Q and this is Q prime. Let me adjust the tangents properly so that the geometry is precise. Okay, now the tangents, the four tangents intersect our two circles at points A, B, C and D like this. And the question is, calculate the area of rectangle formed by the points A, B, C and D. So this is the rectangle A, B, C, D. Okay, so let me adjust it properly, as precise as possible. Okay, so we need the area of this green rectangle A, B, C, D. Let's start the further constructions. Let's call the point of tangency between these two circles as K. Let me adjust this circle. There's a slight gap. Let me place it as precise as possible. So this is our point K. Now I can draw a common tangent between circle O and O prime like this. Let me draw a line which is a common tangent between O and O prime. Let me adjust this. No, I'm not satisfied. Okay, this looks fine. Okay, so this looks fine. Let me call this tangent as S and S prime. This line S prime bisects the line AB and CD, right? Similarly, the line P prime bisects the angle S, P prime, S prime, and as a consequence, it bisects the line AC. Okay, let me call the points of intersection between the line S and S prime and line AB and CD as, let me call this as V and V prime. And the point of intersection between the line P prime and the lines AC and BD as U and U prime. Now, AC is a chord to the circle O. Therefore, the angle AOC will be twice the angle of AP prime C, correct? So, let me draw a line AOC. I'm going to draw the lines AO and OC so that AOC makes a triangle. So from the law of, okay, let me make it. So this is our line AO and OC. So from the law of tangents and circles, the angle AP prime U is also theta, and the angle AP prime U is theta, and angle AOU will be 2 theta. So this is 2 theta. Okay. Now let us start the calculations. The area of the rectangle would be AB multiplied by AC. Now, we said that the line S prime is a bisector of line AB. Therefore, AB would be twice AB. Similarly, the line P prime P is a bisector of line AC. Therefore, AC would be twice AU. So, the area of the rectangle would be 4 times AB multiplied by AU. So now the problem is reduced to calculating the lengths AV and AU. That's what we are going to do. Let me call this as equation 1. So this is our equation 1. Okay, now we will set about calculating the lengths AB and AU in terms of R. Let's look at the triangle PRO. Sine theta. What is sine theta? Sine theta is opposite side by hypotenuse, which is RO divided by OP. RO is R, the radius of the circle O, and OP would be 3R, right? So sine theta equals OR divided by OP, which is R divided by 3R. Therefore, sine theta would be 1 divided by 3. It's a very important result for us in the calculation. So let me call this as equation number 2. Now, in the triangle P prime SK, if S P prime K is theta, the angle P prime SK would be 90 minus theta, right? Because P prime SK is a right angle triangle with right angle at point K. That is, this is a right angle. Therefore, the angle S, let me call this as angle phi, but that will be equal to 90 minus theta. Cool. Now let us look at the triangle AOU. In triangle AOU, I don't like AOU. Let me make it a little better. I'm a stickler for my handwriting. Now, let's look at the triangle AOU. Sine 2 theta would be AU, opposite side, divided by the hypotenuse OA. So, sine 2 theta. Therefore, AU would be OA sine 2 theta and OA is R. Therefore, AU equals R sine 2 theta. Let me call this as equation number 3. So, in our area calculation, we have one side, that is AU is known now. Next, we are going to set about calculating the length AV. Let's look at the triangle ASV. Triangle ASV. Sine phi will be equal to AV divided by AS, which implies AV equals AS sine phi, whereas phi is 90 minus theta. Therefore, AS sine 90 minus theta. Sine 90 minus theta is cos theta. Therefore, AV equals AS cos theta. Okay, so let me call this as equation number 4. Now, the problem is reduced to calculating the length AS. So, in the line P prime S, the length AS would be the difference between the lengths P prime S and P prime A, correct? Let's write like this. Let me call this as equation number 5. So the problem is now further reduced to calculating the lengths P prime S and P prime A, and then we will be the home run. Let's set about the calculation of lengths P prime S and P prime A. Let's look at the triangle P prime SK. In triangle P prime SK, cos theta would be P prime K, that is the adjacent side, divided by the hypotenuse, that is P prime S. Which implies P prime S would be P prime K divided by cos theta. P prime K is twice the radius, that is 2R. P prime K is the diameter of the circle O. Therefore, P prime K is 2R. Let me call this as equation number 6. So we are left with calculating P prime A. Let's look at the triangle P prime AU. In triangle P prime AU, sine theta would be opposite side AU divided by the hypotenuse P prime A. AU we already know from equation 3. Therefore, it can be written as in triangle P prime AU, sine theta equals opposite side AU divided by hypotenuse P prime A, which implies P prime A is AU divided by sine theta. So P prime A would be AU divided by sine theta. AU is r sine 2 theta divided by sine theta. Now, sine 2 theta is 2 sine theta cos theta. So, this can be written as 2r sine theta cos theta divided by sine theta. The sine theta gets cancelled. So, we are left with 2r cos theta. Let me call this as equation number 7. So let's substitute equation 7 and 6 in 5. Substitute 6 and 7 in 5. So what do we have? We have AS equals P prime S minus P prime A, which equals P prime S is 2r divided by cos theta minus P prime A is 2r cos theta. Let's simplify this. We can take cos theta as common denominator and factor out 2r. So 2r divided by cos theta multiplied by 1 minus cos square theta. And 1 minus cos square theta is sine square theta. And sine theta is 1 divided by 3. Therefore, sine square theta will be 1 divided by 9. So, this is 2r divided by 9 cos theta. So, we have AS. From AS, we can calculate AV by substituting this value of AS into equation number 4. Therefore, which implies AS equals 2r divided by 9 cos theta. Let me call this as equation number 8. So, substitute 8 in 4. So what do we have? We have 4 is AV equals AS cos theta and AS is 2r divided by 9 cos theta and multiplied by cos theta. So cos theta gets cancelled. So we have 2r divided by 9. Therefore, AV equals 2r divided by 9. Let me call this as equation 9. Therefore, the area of the rectangle is 4AV multiplied by AU. We have AV from equation 9 and AU from equation 3. Therefore, area ABCD equals 4 times AV multiplied by AU, which is 4 times AV is 2r divided by 9. Then AU is or sine 2 theta. And sine 2 theta can be written as 2 sine theta cos theta. Now we know sine theta is 1 divided by 3 and cos theta I'm going to write it as square root of 1 minus sine square theta. Okay, so sine theta is 1 by 3. So 1 minus sine square theta would be 1 minus 1 by 9. And I'm going to take 9 as common denominator and write it as 9 minus 1, 8. 8 divided by 9, that is square root of 8 divided by 9. Now, square root of 8, I can write it as square root of 4 multiplied by 2. Okay, so we can take out 4 from the square root because square root of 4 is 2 and square root of 9 is 3. So this simplifies to 327s are 81. So our final answer is 32 multiplied by square root of 2 multiplied by r square divided by 81. So how cool is that? So we have 32 multiplied by square root of 2 r square by 81. It's a very cool answer. You have 32 and 81 which are relatively prime and we have an irrational square root of 2 and of course r square is there. So at the first glance, the area of the rectangle looked a bit little difficult to calculate in terms of r. But if you follow the basic principles, it's very simple to calculate and here it is. So let's go to question number 21. Thanks for watching.